So this next video, we've actually already went over this example, but I think it would be a really good review. That way, when you go to do the next example, you have something to guide you through the process. So we're looking at adding and subtracting radicals. Now, one of the things that we talked about on Thursday is in order to add or subtract radicals, they need to be what we call like radicals. And we kind of applied this to the same concept as of adding or subtracting like terms. So if we look at example 5, now again, if you're looking at your note packet, which you should be, this example should be completed for you. So just kind of look at the video, look at your work, just to follow through how we got to the final answer. So we have 4 squared of 18 plus 3 squared of 50 minus 2 squared of 32. Now, obviously, if you look at all three of our radicals, they're completely different. So we can't at this moment add or subtract them. What we can do with each of the radicals, though, is we can simplify it. Now, in the last video you should have watched if you needed a review, that's what we're going to be using right now. So you're either going to be using method 1, which is that cake method, or method 2, which is the perfect square. So if we look at the first radical we have here, and we're breaking them down individually, 4 squared of 18. I'll do this using the cake method. We're going to keep this 4 on the outside. Two factors of 18 that we could look at are 2 and 9. 9 will factor further to 2 times 3 times 3. We have a pair of 3's that's able to come to the outside, which we're going to multiply with this 4. So on the outside, we're left with 12. Square root of 2 gets left behind. We're going to do the same thing with the second. We're going to bring down our operation and simplify 3 squared of 50. So I'm going to do kind of a combination of the perfect square method / cake method, just to make these go a little bit faster. Remember, you can pick any factors, and as long as you break it down all the way to its prime form, it will always work. So 2 factors of the square root of 50 that I could look at are 2 and 25. 25 would then factor to 2 times 5 times 5. We have a pair of 5's able to come to the outside, so this is then going to become 15 square root of 2. We're moving on to the last term here, square root of 32. So we still have this 2 on the outside. 2 factors of 32 that you could possibly look at, and again, I'm just doing this to make it a little bit faster. 2 times 16, square root of 16 will factor to 4 and 4, and each of those 4's, we're going to be a little off track here, but you'll see, will factor to 2 times 2. So in total, we have 2 pair of 2's that are able to come to the outside, but we also have another 2 on the outside. 2 times 2 times 2 gives us 8, square root of 2. Remember, it's always multiplication. From here, if we now look at each of the radicals, we can see that they're all dealing with the square root of 2. Now, when we go to add our like radicals, just like variables, we're only adding their coefficients. So we're adding from the left towards the right. So 12 plus 15 is 27. 27 minus 8 leaves us with 19. We leave the radical as is, just like we would any variable. So your final answer for this would be 19 square root of 2. So what I'd like you to do now, pause the video and work on example 6.